Welcome to this section of the course. Here we'll be discussing what's a function and mapping, and what's a domain and what's a range. Okay, let's get to it. Okay, let's look at the mapping diagram. Mapping diagram is basically one set pointing to another set. Okay, so we've got -3 mapped onto 0, 1 is mapped onto 4, 4 is mapped onto 7, and so on. What do you think the mapping function is? It's x plus 3. If we plot it, it will look something like so. Every x value maps onto y value. X values are called the domain of a function. The y values are called the range of a function. The range is sometimes referred to as codomain. Okay, so let's see another example. Here we've got -1 and +1 mapped onto the same number. -2 and 2 are mapped onto the same number. This function is function of x squared. That's this kind of a function is called many-to-one function. Many-to-one because we start with more than one input, but they point to the same output. Okay, this is not a one-to-one function. Okay, in the previous example we saw a one-to-one because every unique value of x was mapped onto unique value of y. Alright, let's consider what constitutes as a function and what doesn't. One-to-one functions are unique. Each input maps onto unique output in the output set. Many-to-one functions, on the other hand, don't have a unique output. They don't have a unique input. Okay, so as we considered, x squares are, even if you put them if you input a negative number into x squared, it will give you the same output as a positive input. Okay, let's see what's not a function. What's not a function is 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 algebraic definitions that are mapping two inputs to the same output. For example, square root of x or 1 over x. Square root of an x Okay, so let's see what constitutes as a function and what doesn't. In the previous two examples, we saw an example of one-to-one function. A linear function, such as 3x minus 2, is a one-to-one function. And many-to-one function is, for example, x squared. But what doesn't constitute as a function is when you have two outputs, one output pointing to two outputs. So one input, for example, let's take a square root. If I take a square root of 4, I will have either a positive 2 or a negative 2. Now, if I had to find the inverse of this function, I wouldn't know which of those two values the 4 came from, right? Or let's take any other output. Let's take another input. Let's say we have 3. If we take a square root of 3 or 9, if the square of 9 would be a positive 3 or a negative 3. If I had to find the inverse of square root, I wouldn't know whether I should go from 3 to 9 or from -3 to 9. So we have to put some boundaries if we have to find the inverse of a square root. I'll discuss that in later slides. Right, so one more time. There is a quick and dirty way of calculating. Okay, So how can we decide what constitutes as a function or not? If we have a graph of a function of certain certain graphs, we can draw a vertical line. If a vertical line just touches the graph only at one point, that definitely is a function. This is called a vertical line test. If we do it for x squared or negative x squared, you get for any one input, one output. So that's fine. But what's consider the graph of a square root or a circle. If we draw a vertical line, we'll have two intersection points. So this is breaking the rules of vertical line test. Therefore, a circle, if you see equation of a circle, that doesn't constitute as a function, or in this case 1 over x. The vertical line test doesn't cross the graph at x being equal to 0. Therefore, if we had to make this 1 over x a function, we have to justify and exclude the fact that x could be 0. So by by including x not equal to 0 as the domain, we can make this kind of function, uh, make reciprocals a function. Also, if I drew you the graph of the square root, it would look something like so. And if we drew the vertical line test, it would cross the graph at 2 points. That would break the rules, and therefore square root cannot be a function, or if its inverse cannot be found easily. To make sure that the inverse is 1 to 1 and on 2, we can justify the range and take positive values of x squared. That means that we can exclude the lower half of the graph, and then we can take the inverse. Okay, so we'll see that in more detail next. In this example, we are looking at 2x squared plus 3. So we've been asked to calculate the function value when x is 3. All you have to do is substitute 3 for x. The next example, we've been told the output is 35 and we've been asked to calculate what's value of a. All you have to do is take the inverse and substitute 35 as the output and solve it for a. Subtracting 3 gives us 32, divide by 2 and take the square root. Now a could be positive or negative 4. Now we've been asked to work out the range of the function. Range means y values. So what y values can be given to us? If you consider the graph, this is x squared graph that has been stretched by a factor of 2 in y direction and has been translated upwards by 3. So the lowest value that it can take is 3 and the highest value is positive infinity. So you could say the y value goes from 3 to positive infinity. So we write g of x bigger than or equal to 3, and that's the range. So notation, x is a member of R means that R is any real value. Real values have decimal points, and real values include positive infinity to negative infinity, unless you exclude any values that you want with inequality signs. Okay, so we are looking at positive half of the square root. We said that if we have a vertical line test, uh, the square root cannot be counted as a function itself. Therefore, we have to bound the range of the function so that we can find its inverse. We restrict the domain so that the x values are positive as well, because we cannot take the a square root of a negative number. Okay, So not only the output, but the input also needs to be restricted. Okay, so the notation here means that x is any real number as long as it's positive or equal to 0. In this function, we have 3x minus 2 as a definition, and the domain is only discrete values 1, 2, 3, and 4. Okay, so the range will also have discrete values. Let's see, we will get 1, 4, and so on. This is the definition of a one-to-one function. Right, so in this next example, we consider the graph of, or the function for x squared. The range of the domain is restricted by 5 and minus 5. Therefore, the domain will be restricted from 0 to 25 because the highest value the y value can be is 25. So you use inequality in this manner. This is many to one function if you had to describe the function. So 1 over x, given that the domain is between 0 and 3. This case, because we've restricted the domain and we've excluded the 0 from domain x, and then we are saying that x is strictly bigger than 0, that's enough to make this a function. Let's plot it. So the range of output we've been asked to calculate. Because the function is a reciprocal function, the lowest value for x will actually give us the highest value for y. The lowest value for x is a number close to 0, but not 0 itself. So it can go up to infinity, because we can always choose a lower value as a real number close to 0 and divide by that. That would give us actually positive infinity. So, and the lowest value for range is where we have the highest value for the domain. Highest value for the domain can be 3. So 1/3 is the lowest value for the range. The output of a function will always be bigger than 1/3. Okay, in this particular function, we have this particular function is called the piecewise function because when the domain is less than 1, that is x is less than 1, we have 5 minus 2, 2x, which is a linear function, and when the domain is bigger or equal to 1, the range of a function is defined by x squared plus 3. We plot the graph, it will look something like so. Okay, in part B of this graph, in this question, we've been asked to find the values that f of a equals to 19. So, looking at the graph, the output of 19 can come from both parts of the graph. It can be either from the red line or on the blue line. So we will solve both of these equations. We've set the output to 19, and x could be either minus 7, or if we take the quadratic part, x could be either 3, either 4. Well, it can only be positive 4 because when it's x minus 4, we'll be using the linear version of the graph. Okay, let's look at the next example here. In this case, we have a piecewise function because the domain is divided into two sections, and when x is less than 1, we have a linear equation. When x is equal or bigger than 1, we have a quadratic equation. So, we've been asked to sketch the graph and state the range of possible outputs of this function. So let's see. When we plot the function, we'll have a linear line with a negative gradient for all values less than 1. The intercept will be when x is 0, and the intercept will be 5. So it will look something like so. Then we will look at the quadratic part. For any value bigger than 1, we substitute x into the function and we'll get something like so. In fact, the correct way to show the output is to include a, a fill dot here, a solid dot, and use a open circle here, because open circle indicates that the value of 1 is not, the input of 1 is not actually included in the red line. All right, so what's the range of this function? Range means output, or y values. Y values can be any positive number as long as they are bigger than this y value here. This y value is 3, but 3 actually is not included. Therefore, we write y, or f of x, rather, f of x is strictly bigger than 3, because 1 cannot be substituted, but as a number slightly bigger than 1, such as 1.0001, may be inputted into the function. So the output will be just slightly bigger than 3. So then we are looking at part B of this question here. The part B is asking us to find values of a such that f of a equals to 19. This a. Then to solve this part of the question, we can see that the y values are 19 either on the left or right or on the right. Therefore, we have to solve two equations to show the answer here. We first of all write 5 minus 2x and set that equal to 19 and solve it. We'll get minus 7. When we put x squared plus 3 equal to 19 and solve it, we will end up with two answers. But can it be minus 4? Pause and think. No, it can only be positive 4 because when x's are negative, we would have used the linear equation. Therefore, the answer is either minus 7 or positive 1. Okay, so I hope you found this helpful. I'll see you in the next video.